Okay, good afternoon, everyone. I'm Don Coyne, current CEO of ANZ Biochar Industry Group, acronym ANZBIG, and I'm joined today by Sam Sagami, our cluster manager. On today's episode, we will be discussing the testing requirements for biochar to meet our new sustainable production and use of biochar in Australia and New Zealand. In today's podcast, we will discuss how a laboratory becomes accredited itself and the various testing suites available, as well as costs.
And to help us discuss the topic, we have Graham Lancaster, who is the Laboratory Manager from Environmental Analysis Laboratories in Southern Cross University at Lismore campus. EAL has now successfully operated for 30 years next year to subsidise research at Southern Cross University at a zero cost to the university. He is also an active member of our advisory board.
Welcome, Graham.
Thank you, Don. Thank you, Sam. I should correct a little bit of slightly different title now. I'm Commercial Research Manager. So I'm looking after EAL and another laboratory called Analytical Research Laboratory, which looks at plant chemicals and natural products. So a diversified position, but great to be part of the committee here with biochar. And it's an interesting subject that we need to know more about.
Yeah. So on that note, Graham, can you just give us a bit more background on the establishment of the lab and perhaps both labs, your role there and I guess the range of clients that you service?
Yep. So basically, my role is to look after both labs now, like I mentioned, but I set up EAL 30 years ago, which is a long time. And EAL's been a national but international laboratory, and we're very diversified, running everything from soil testing, water testing, manufacturing, council work, obviously biochar, biosolids, human hair testing for metals and contaminants. So it's very diversified. So we have around 50 staff that do a hell of a lot of commercial plus research work. So it's diversified, and we do nationwide and international samples. So there's quite a market there. Owned and operated by the university, but we also have a laboratory called ARL, Analytical Research Laboratory, and they look at natural products. So they start in the tea tree oil industry, looking at tea tree oil, natural actives, and a lot of natural creams, and a lot of natural companies. So very much in the health field, but manufacturing, and it's another commercial and research success story in the university.
Really interesting. And what qualifies a laboratory to be NAATA certified, and why is it important that people use only those accredited labs for analysing their chars and other products? Yeah,
a good question. I mean, laboratories are all about quality assurance this day and age. For environmental type laboratories, NAATA is what we call it, and it's National Association of Testing Authorities, and it's ISO 025. It's one of the accreditations worldwide, 17025, and it looks after making sure that we give the right results. So all our testing's done to those standards. And we've been NAATA now for about 15 years in the university. So we're the first university in Australia to get NAATA accreditation. But we're also ANZBIG accredited. So that's Australian Soil Plant Analysis Council. So they concentrate on interlaboratory testing in the agricultural field. So in the biochar, agricultural is quite a similar related field. So we think it's important to also have that accreditation. So it really means that your results are peer reviewed. They're looked at by other laboratories. We do a lot of interlaboratory testing, and that's something we need to promote more and get organised more in the biochar industry to get interlaboratory testing happening, to really get consistency in laboratories. And that's what NAATA wants. It wants to see consistency in what you run, what your methods are, and all your analytical procedures. And biochar are a tricky analysis. We've learned a lot over the last 3 or 4 years in doing that testing. It's quite particular and quite narrow in getting the right results and meeting the requirements of the code.
Yep. Great, thanks, Graham. And on, I guess, yeah, can you then now elaborate on those biochar testing suites that EAL is offering and how it meets the requirements of ANZBIG's code of practice?
Yep. We've tried to customise, and we'll be continually developing these over time, a bunch of suites to meet the requirements of the code. So we have really one of our main packs there, SS Pack 163, which you have on your website, which is a totals analysis with ultimate analysis, which is your hydrogen and your oxygen. And really, we've customised that. We do most of this in-house. All our metals and salts we do by ICP mass spec, which is inductively coupled plasma mass spectrometry. And that's to get that maximum detection level. You've really, in biochars, you are looking at trace levels of metals and that sort of thing as part of the code and the classification. And you also need very accurate carbon analysis. So we use LECO combustion analysis for that, for the carbon, the nitrogen, the sulfur. And then we have other combustion analysis for the hydrogen and the oxygen in-house. So we have all this facility in-house. Acid neutralizing capacity is also part of that suite. And we also learn a lot that the ashing analysis needs to be done at 750 degrees. And that needs to be done quite precisely, because we found that even 550 degrees will get different results for biochar because it's already been ashed. So we're re-ashing effectively in controlled conditions, on oxic conditions compared to anoxic conditions, which is typically for your biochar production. So that's all done. And then we have a bunch of other suites. We do have to subcontract where we can't do in-house, and we have a lot of arrangements with other labs for that. Currently, the dioxins and furans are very expensive, but they need to go overseas to get to those detection limits. So there's some time restrictions there and some extra costs there. But we have a variety of suites, even the PCBs and PAHs. Ultimate density ashing, full volatile organic carbon and semi-volatile organic carbon suites. You can even just do the heavy metals separately. So we're trying to give maximum diversity and options there for clients to get really what they want to do is monitor their biochars.
And have these testing suites been used in other industries? And if so, which ones?
Oh, look, we not specifically. It's a specific code we've got there for biochars, but we do a lot for biosolids. We do a lot for recycled waste, do a lot of agricultural soils, contamination, environmental contamination, soil. So all these testings are pretty well routine for other industries. It's just we've adapted them more specific for the code of standards and for meeting the biochar requirements. We've always, being a research commercial organisation in a university, we've always targeted to get the highest accuracy we can, but also meet those really low detection levels. So we do everything by mass spectrometry to get those trace levels. And for all the other analysis, we try to get that really low level of detection to really help hit the research services and meet the requirements of our researchers as well as our commercial clients.
Right. And so do these testing suites meet the various regulator requirements? If so, who are they? And what should producers and users look out for when they're analysing their biochars?
Yeah, you do have to get to yes, these suites meet the very low level of detection required. We need probably 500 gram to a kilogram of biochar in a sample, probably more like the kilogram, to make sure we've got enough volume requirements there, because that could be a restriction if it's not enough volume. But it's all about getting those trace levels. So you've got to make sure the laboratories can meet those detections. Some of the critical detections are obviously the PCBs, the PAHs. Each of those heavy metals have a specific requirement for each of those metals. So you can probably provide a cutting from the code to your laboratory and say, this is what's required. So they need to be done by ICP mass spec to get those low levels for the metals. And other detection should be done fairly routinely by those labs. It's required by EPA, by governments, organisations, by health authorities, by councils to meet those requirements. So the code's fairly new, obviously, so it's going to take a time to settle in. But I think it's about the industry sort of leading it there and saying this is what's needed.
And how often do you feel like these, these tests need to be done?
Look, I think we've tried to make a price so that our routine suites at a couple of $100 can be done fairly routinely on a batch or a quantity truckload. I'm not sure. They haven't really specified, I think, size sampling at the moment, but it's about getting a representative sample. If you know your input and you're not changing those inputs regularly, then maybe you don't need to test as regularly. But if you've got input changes all the time, then you're going to need to test fairly regularly. Once you're moving into the more expensive, the dioxins and furans, then I think the industry is going to have to dictate where you need to do it, and you're going to need to get advice on that. It might be just a once-off as your products change and your risks change. So it's all about risk management, knowing what your input is. If you're using roadside waste, then you're going to need to test metals very regularly because they can be a big impurity. Lead, mercury, arsenic, you name it, it could be in there. PCBs, PAHs can be regular contaminants. So it's really about knowing your products and knowing what you're doing developed as an industry, but then as a purchaser to be aware that metals are probably one of your main contaminants that can be concentrated. If you're using a biosolid type input, then you're going to have higher accumulation because it's often a bioaccumulation. It's an accumulation in the process of metals that generally don't volatilize.
All right, and so you have been analysing biochars for a number of years now, although you've just updated these suites recently to match our code. But have you noticed any trends at all in the analysis of biochars coming in over, say, the last couple of years, last 12 months?
Yeah, but I think it's getting more regular, the testing. And there's getting more demand for it over the last 12 months. So I think the code's just setting a standard that people now know what they're looking for. They know what they can compare their heavy metals to. It's all about classifying your biochar, and obviously that's done on carbon, so that's probably your first step. And we do get a lot of diversity in biochars from 30% carbon right up to 95+% carbon. So there's an extraordinary range of biochars out there, and the code reflects that. And I think that's the most important thing. It's hard to say the purity's changed or there is changes or trends happening in the industry yet. That's going to take time because there is just such a diversity of products out there. So biochars ain't biochars, as the old thing went. So you've got to know what you're getting and what you're buying and what you're selling. So that's where analysis is so important. I think they can look similar, but when you come to the analysis, they can be very, very different products.
Yes. Yes. Yes.
And you mentioned carbon. The theme of our conference this year is biochar in the carbon drawdown decade. How do you see biochar rolling out in Australia and New Zealand, and the role ANZBIG accredited biochar will play?
Yeah, look, I think it's a fantastic player. I don't look at any one player as being more important than another. I think compost is very important. Natural products in fertilizer products is very important. But the biochar itself is just such a player in producing that inert carbon, but also producing a carbon in a form that some of the carbon that's there as a biological media and a housing for biological organisms. So in agriculture, I think it plays a very important role. And for carbon sequestration, obviously the numbers are already there. It does create the numbers you want for sequestering carbon. So even a local macadamia farm here I was just recently at, they were talking about 100 tonnes of biochar they've just purchased and they're spreading around their farm. Now that's one farm and they're looking at the carbon credits they're bringing in with that and looking at the changes in carbon with depth. So I think the science is out there and it's being developed all the time. And I think it's a no-brainer. I think we've got to get the biochar happening, we've got to get the compost happening, and we've got to get the farm management happening to really make it worthwhile. If you don't bring it all three together, in a lot of cases, I don't think you're going to get the full results. So we want to see the biological activity in farms increasing, and we want to see management of those farms to be optimal to really handle all these new products and new developments.
Yes. Yes, and also known as pyrogenic carbon capture and storage. So,
all the terms they got these days, I imagine all your clients are confused like all hell on the
but yeah, what you're saying is regen ag, sustainable farming and land management practices.
And look, we've
carbon in the soil.
Yeah, we've got our new Regen Ag degree at the university here. It's the first in Australia. It's hugely successful. We've got about 350 students now that are doing that degree online and coming online to the university when COVID allows. But it's fantastic at just promoting those regen techniques. And I know they're a big supporter of biochar as well. So, yeah.
Yes. It's really good to hear, because that was going to be my next question is, are they including biochar as part of what they're teaching at universities when it comes to regen ag? I
think, like I said, it's just another tool, and there's so many tools in the quiver for people doing organic biochar, regen. It's just all that biological story, and it's just definitely another tool that is used. So I don't like to look at one thing over another. Like I said, I think it's just all part of the puzzle that we're trying to answer, and I think we're putting that puzzle together pretty well these days.
Yeah. Thank you, Graham. And of course, we've partnered with you, with SCU, on a biochar and regen ag project out at Soft Agriculture at Malangani. So we're feeding biochar to cows and observing the health and any weight gain. And we're also doing some pasture plot trials out there with different treatments. So it'll be very interesting to see the results from that over the next couple of years.
Yep.
And I want to thank you for sharing with us today. Your testing suites are on our resources page at anzbig.org/resource. But what's the best way for people to get into contact with you directly?
Just really our website, I think, our eal@scu.edu.au, which is just a simple email, and that just gets forwarded to our senior staff who can answer queries. Okay. We generally have a couple of week turnaround time for a routine analysis. We do agricultural soils in a week and plants in a couple of days, but the biochar is a bit more involved, so it takes a little bit longer. So we try to be a one-stop shop, and yeah, we're available.
Great, thank you again, and thank you to Sam Zagami, our cluster manager, for co-hosting, and all the viewers and listeners for joining us. We hope you found today's episode value. This is the final episode in our first podcast series, Biochar and the Carbon Drawdown Decade. So to keep up to date on our latest episodes, you can subscribe to ANZBIG's YouTube and Vimeo channels, or follow the Biochar podcast on Apple Podcasts or Spotify. So until next time, chars.
Thanks, Don. Thanks, Sam.